Okay, we are going to continue with the fundamental theorem of calculus, except today we're going to talk about the second fundamental theorem of calculus. All right, so the first fundamental theorem of calculus was basically a definite integral, right? Second fundamental theorem of calculus is a nice little concept. Derivative and antiderivative. If we put them together, what happens? Okay. Grant, that is exactly what the fundamental theorem of calculus is. Go and write it down, and then we'll talk through it. Okay, take a moment and discuss in your pod why this makes sense. Talk it through. Why would this make sense?
Yeah. Just taking the derivative of the integral just bring you guys to the same place. Because an integral brings out one, and then derivative becomes or if you even think it the other way, we'll bring it down.
Okay. Logan, I like what you said. What did you say when you turned to Connor?
I said that the antiderivative is one integral higher, and then the derivative is one lower, and so they kind of just even each other out.
Okay, what's the word that you use though? Use a different word than even each other out.
I don't remember.
What's
the first letter? Undo each other.
Okay.
You get the word.
And what is Jake's word?
Definition. You just get to find it.
All right. Logan said they basically undo each other. Okay? The derivative of the antiderivative, they basically... Okay, when you take the antiderivative, you get to the function, and then when you take the derivative of that, you get back to what you started with, right? Now, what I want you to notice is that this is f of t dt, but then this is f of x. Why is that?
Because functions are second. Technically, because f of x is going to be a different function than f of t, because f of t is just denoting that's the integral.
Well, they're going to be the same function, except this one has t and this one has x. Because they both say f, right? Okay. When we take the integral here, we're going to plug x in minus, we're going to plug a in, right? So we're going to have something in terms of x, and then we're going to take the derivative with respect to x, so we better get something in terms of x. Okay? So, let me demonstrate this here. If we take this right here, we're going to get the antiderivative of f evaluated from a to x, right? Fundamental theorem of calculus says f of x minus f of a, right? Well then, if we're saying, okay, we're going to take the derivative of this with respect to x, well, the derivative of the antiderivative means we go back to the function, and the derivative of a constant is 0. We don't have to worry about that f of a because it's going to go to 0. Okay? So essentially what you're going to do, this is the variable you're going to plug in. We take the fact that a derivative and antiderivative undo each other, and we're left with the original function. Go ahead and write this down. Okay, so I'm going to flip back to the slide before. The integral from a to x. A is a constant. It doesn't matter what it is. Negative 100, 0, 3, 10. Doesn't matter as long as it's a constant. And then x is up here. Okay, so we have the integral from 3 to x of t cubed plus t dt. And then we have the derivative of that. Okay, so a derivative and antiderivative are basically going to cancel this out. So we're going to plug this limit of integration in. And we're done. Okay, that is using the second fundamental theorem of calculus. Okay, now we could take the long way. Okay, don't write this down, just watch, because I don't want you to think that this is what I want you to do. So just put your pencils down, okay? If we take the integral from 3 to x of t cubed plus t, the antiderivative of t cubed plus 1 is 1/4 t to the 4th plus t. Do you agree?
Yeah.
Evaluated from 3 to x. Okay. And so we have the derivative of 1/4 x to the 4th plus x minus 1/4 3 to the 4th plus 3. Okay, so now if we take the derivative of this, the derivative of 1/3, 4th x to the 4th is x cubed. The derivative of x is 1, minus the derivative of a constant is 0. We have that original function. Okay, so the second fundamental theorem of calculus is just saving you from doing all of that work. We like shortcuts, right? Okay, this is a shortcut that you're allowed to take. Okay, do not do this. Write this one down. Joe, what's this answer?
E to the x squared, so then,
You said e to the x squared?
yeah, so then take the derivative of x squared.
Actually, we don't have to. Okay? It's, if we were going to have to do a chain rule, Joe, it would be if something other than x was right here, and we'll get to that. Okay? The answer is just e to the x squared. We're done. So nice, right? It's like hardly any work, right? Okay. Now, write this down. Okay, Cole, what's our difference?
Constant where the x should be and there's an x where the constant should be.
Okay, the x and constant are flipped. Why? Okay, remember we have that property that the integral from a to b is opposite of the integral from b to a. So what we need to consider is that in order to be able to use the fundamental theorem of calculus, we need this to be the integral from 7 to x, which we know is going to be the opposite of the integral from x to 7. So now we can say, all right, a derivative and antiderivative undo each other, so we have negative sine of x squared. What did? Okay, write this one down. What's different about this one? We have x cubed. So we have a function inside of our limit of integration. Okay? What do we typically do when we take derivatives and we have a function inside of something? When we take the derivative and we have a function inside, what rule do we use? Say louder. Chain rule. Okay? So since we have an x cubed there, first of all, we need to replace t with x cubed. First of all, that t gets replaced with x cubed. But then we have to consider we're taking a derivative and we have an x squared, or excuse me, an x cubed. We would usually have an x on that limit of integration. So we have to consider the chain rule. So we multiply by the derivative of what's inside. So we have 3x squared radical x to the 9th plus 1. And that's our derivative.
What's that say number? 12, 10?
Yeah.
We're in 6.
Yeah.
What's why?
It's because these problems are short, right?
Do we get longer?
We're going to switch to a different gear here soon, but... Okay. All right, go ahead and write this down, please. This is another way you will see these problems. It is not written the same as they have been on the other slides. So please write it down like this so you have that in your notes. Okay, this is asking for the derivative of an integral. Okay, so it's essentially asking us for the same thing, it just looks different. Okay, they're still asking for the derivative of the integral. So at your table, come up with a common answer. This means you probably have to talk to each other.
3x squared.
That's your chain rule? Because I thought we did chain rule last time because it was X on the third on the side.
This is what we did. Yes. Yeah.
Never mind.
Okay.
Jaking it through that. That was your fault.
Okay, pod 4, what do you have for an answer?
What pod is that?
What's this one right here?
You need them on the back.
I do. Like that? Do you agree with pod 4? Good, because it's the right answer. Okay, we put x cubed into our function, and then we have to worry about the chain rule. Logan asked a good question. Okay, the chain rule applies when you have something other than x as your limit of integration. Okay, it doesn't matter what's in here. Okay, what matters is if this isn't x, then we have to worry about the chain rule. Okay, so you will have book problems that deal with this second fundamental theorem of calculus. Okay, and we're going to do a little bit more with it tomorrow when we talk about graphs and accumulation. But I want to come back to a concept that we've kind of talked about, but it's going to look a little bit different. All right. I want to go back to the first fundamental theorem of calculus and our concept of differential. So I want you to go ahead and write down this information. Okay, we're going to do a side-by-side here. There's two different ways we can do this problem. Let's go back to the very first week of the semester. That seems like so long ago, right? F prime of x equals 4x. Okay, that first week of school, if I were to ask you, hey, find f of x, you would say, all right, well, f of x is just the antiderivative of 4x. Right? Which means our function is 2x squared plus c. Right? Well, we know f of 0 is 6. And so that week we said, all right, we can plug 0 into x, which means we should get 6. And so we can figure out that our c value is 6. Okay. So our function, f of x, is 2x squared plus 6. Do you recall doing that? Okay. Well, now I'm asking you to go one step further. Find f of 3. Okay. Well, f of 3 means we're just going to plug 3 into our function. So f of 3 is 24. Okay. So that's what we did way back first week of school. Okay. Now, how I would like to show you how to do this problem is using the fundamental theorem of calculus. Okay. So remember, the fundamental theorem of calculus, the integral from a to b of f of x equals the antiderivative of b minus the antiderivative of a. So what we can do here is we can say the integral from 0 to 3, where am I getting 0 and 3? Those x values right there. the integral from 0 to 3 of our derivative should give us the antiderivative at 3 minus the antiderivative of 0. If f prime is in our integral, then function f would be its antiderivative. Okay, so now all we have to do is evaluate this integral. So we have 2x squared evaluated from 0 to 3 equals f of 3 minus, we know f of 0 is 6. So we can evaluate our integral. We're going to get 2 times 3 squared minus 2 times 0 squared, which is 18. And then when we add that 6 over, we get f of 3 is 24. Okay, so we can actually use the fundamental theorem of calculus and not even have to worry about what the function really is. Okay, so this is what I'm going to do. We have a little more than 10 minutes left in class. What? Okay. I am going to give you a worksheet that will help you practice these skills right here. And then I'm going to and then on the back of the worksheet, I want you to do some book work, okay? So I'd like to get organized. What I think you should do is do the worksheet and on the back put the book problems, okay? So I'm going to hand out the worksheet and I'm going to make each and every one of you write the book problems on the back. Okay, so on the back. On the back, page 290, 81 to 91 odd. Okay, so maybe you want to do those first. Maybe you want to do the worksheet ones first. If you look on the worksheet, 1 through 4, you're just finding f of x. But 5 through 7 on the worksheet look like what we just did up here. I don't care how you do it. Using the fundamental theorem of calculus, it takes less steps, less work. And I think doing the fundamental theorem of calculus will help you when we get to more of our calculator work next week. Okay? So, the time is yours to work on your homework. A rare gift. Use it wisely.